This video is going to serve as an explainer of the path demos code that we've worked on a couple times, but we have left it alone for a while, so I think it's worthwhile to go back and go through the various sections piece by piece, run it on Colab, and then run it on the Mac to see the impact on your local machine. So for this section, we're going to be looking at what I've labeled Part A, which is really going to focus on the path and the OS modules that were being put to use for this bit of code. So the two big things that are going on is on line 5, we're having the computer use the path module to get the current working directory. So that means where we currently are, the whole path that we're currently in, wherever we are, whatever machine, whether it's Colab, PC, or Mac, this would grab whatever directory that we're currently in on the machine. And then it's creating a variable called working directory to store that information. So basically it gives us a starting point of where we are right now, file-wise, on our machine. And then the very next line, line 6, is going to add on to that a new spot, a new folder called Python tutorial. So by having working directory with the forward slash, what it's telling the computer is that we're building on, we're concatenating the working directory where we currently are and adding on an additional piece called Python tutorial. So that's really just going to be part of a path, and we're calling that new folder. So that'll keep track of the new location that we want to have our file go to, so it'll be stored in its own folder called Python tutorial. Right? And then the last two little pieces here, 9 and 10, are using some print statements just to give us an update on where we currently are and showing that on the screen so we can see the current working directory is, and then whatever was retrieved from when we got the current working directory using the path module. All right, that's it for Part A. And for completeness, just to show when this code runs then, here is the output of lines 9 and 10 down here. And you can see that it says current working directory is, just as line 9 indicates it should print. And then line 10, the output is this, users/jci/downloads. And if you take a look, actually up in the listing of where this file is, it is in users JCI downloads. That's where the file lives. So it makes sense that the path that we're seeing is exactly where the code that we're running is. That's always going to be the case. So there is the output that gets generated from lines 9 and 10 right there. And the next chunk we're going to take a look at is really the bulk of the code that involves the writing of files. So that's the part that's highlighted now. And there are several things going on here, but for Part B, I'm going to focus on the parts that are doing the file work. So line 16 prepares a file pointer called F1 to be pointing at the new folder that we've previously set up on line 6, and then it's going to give a file name of helloworld.py, and it's going to prepare that file pointer for writing a file. So that's a lot of work going on in that one line, line 16. So it's really nice because it does all that stuff in one line of code, so pretty efficient line of code. Shortly after that, then we have a call to the operating system module, and it's using the makeDirs function / method to actually create a new directory or a new folder on our operating system. And the folder it's creating is the one we set up previously again on line 6. So this call actually makes a new folder, new directory on whatever machine we're running this code. line 19 is actually a lot like line 16. So we'll talk about it and why it's here when we get into part D, which is talking about the try and accept. So hold on to that because it really is the same code, and there's a reason for that. All right, so then continuing on with file writing, line 24 actually writes the code that was stored in a variable called code1 to the file as we indicated. And then because we did an open of the file previously, we also need to then finalize and do an F1 close. So that wraps up F1 to be all finished. And then the last little bit of file writing that we have is for a second file. This one uses the with open, so we don't have to specify a close command since it does it for us. But it's also using the same folder we were at before. It is specifying a new file name. It's still in the write mode, and this one is being specified as F2. And sure enough, on the very next line, that file is written, and because we use the with open, and as soon as that block finishes, it automatically closes it for us, and that takes care of all of our file writing. So I've called this part C code tricks, and it's really just because we're using two variables on lines 12 and 27 to hold on to a string which just happens to be really short snippets of code saved inside of a string. So code 1 is actually defining a function called hello, and it has one thing it does, which is just print out this is imported from hello world. And then code 2 is another variable that has one little piece written inside of it, which is an import statement. And the trickiness, so to speak, for that is that each of these strings then can be written to a file, and because they're saved as Python files, it's actually making two little programs out of these two strings. So that's really the trickiness behind using code 1 and code 2 as variables that happen to hold some instructions in them. We then write those to files with F1 and F2. So for this last block, D, we're going to be focusing on the 4 pieces of the try except block. And there are 4 different components to this: the try, the except, the else, and the finally. So just as a reminder, try is a piece of code that we can use to say, attempt to do the following line of code, and if it were to generate an error or some kind of exception, then handle it gracefully rather than having our code crash, because then nothing else of our code would run. Wherever the error occurred, boom, we're done, and anything else that was supposed to happen didn't. So in this case, since we're using the open command, it makes sense to verify that we can do this, that this thing exists before we actually try to write a file later on to that spot. So try is there to attempt this code and handle it gracefully. Now, if it were not to work, so if that would have produced an error, then this line, except file not found error, is going to basically intercept it and not crash. And we're kind of making the assumption at this point that the reason it might have failed was that that folder didn't exist. And to get around that as an issue, then we can use the OS make dirs command to create a folder so that the folder that we're trying to write to actually does exist. So this is kind of a workaround to say, if you were trying to write out to a file but that area didn't exist yet, go ahead and make that area for us so it will work. And then this is why line 16 and line 19 are pretty much identical, because if on line 16 it wasn't able to do that, then it didn't successfully create F1 to have a pointer to the file that we're trying to write, which is going to be called helloworld.py. So if that did not succeed, once we've made the folder on line 18, we're rerunning that same pointer to point to the file that we want it to do. So in case we didn't succeed on line 16, line 19 is trying it again after having created the folder that probably didn't exist in the first case. This block also does include a little print statement, so we get some output that says create a new folder for file path. So this is to let us know as the user that this did happen, that the code did go into the accept block and it did create a folder for us. In contrast, the else portion of the try block says if you succeeded with this try, then this would have run, the accept block never happens, and then the else says go ahead and do this and let us know that this happened. So we have some output there. And then last but not least, the finally block. This happens every time the try accept block takes place. So regardless of whether it failed or succeeded, the finally block happens. And one really good reason to use that is if we've previously opened a file with the open command as opposed to the with open. So on line 16, notice that we just did the open directly, and that means at some point we need to close that file too. So line 23 through 25 have the important job of saying send out the actual stuff to the file, and then last but not least, close that file again for us. So there you have it. That's why we have the try, accept, else, and finally block within this code.